welcome to PTN, your 24-hour physics television network.
Thank you, Craig. Today we're going to be examining a half trajectory using a video of Craig doing an ollie over the Schoffen-Steffen stair. Craig, why don't you go show us some of that?
Alright, but first, let's check out some of that dope footy action. BAM! That was amazing.
So, we're going to now examine the velocity before the actual jump off the ledge. Why don't you show us some of that, Craig?
Come on! Welcome to the chalkboard. First, we're going to pick apart. Let's pick it apart. The beginning. 1, 2, 3, 4, 5, 6, 7. Right here to here. We want to check out the velocity and the acceleration before the half trajectory. Boom! Alright, first of all, our distance is key in finding the velocity. Our velocity can be found by dividing distance over time. Our velocity equals about 6 meters over a 2-second period, giving us a velocity of 3 meters per second. Oh yeah. Now, I wasn't always going 3 meters per second. I started out at 0, meaning my V naught, 0. Velocity, 3 meters per second. By plugging this into the formula, V equals V naught plus AT, A equals our question, T equals 2 seconds. Alright, velocity. Excuse me, made a mistake. Everyone's human, except animals. 3 equals 0 plus A2. 3 equals 2A. Divided both sides by 2, some simple algebra gives us A equals 1.5 meters per second squared. 1.5 meters per second squared. Well, I'd say we picked that one apart like a lion eating a lamb. Let's head back to the table.
The music is coming in to Jackie's outer ear, also known as the auricle, where the sound is grabbed and concentrated into a smaller area. It then passes into the middle ear, where the sound is amplified by the eardrum and the ossicles. It then goes past the eardrum and into the oval window where the cochlea is, and then past the auditory nerve and into the brain, where Jackie interprets it.
Oh, yeah! My ear hurts so bad, I wish I knew how it worked.
Well, we'll tell ya!
What?
So if you're listening to your music on more than 120 decibels, you're passing the threshold of pain, and that means you're causing permanent damage to your ear. And
I've lost my hearing, and I would do anything to have it back.
Well, Craig, that was an amazing display of velocity.
Well, Scott, all I can say is
That was easy.
ha 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 ha.
It
Some TV
really
humor.
was amazing, though. Craig,
Thank you. Thank you.
I love you. I love you too.
Now, we're going to take those numbers that I received by using those formulas, hopefully they are right, and apply them to the half trajectory formulas and use them as givens. Let's head over to the chalkboard. Hey, every day, yeah.
Now we're going to take those numbers that Craig found for us and put them into the half trajectory formulas. And we're going to find out how far he went, how much time it took, and that's about it. So, here is the stair set. And we're going to find out all the information for this trajectory. Now, what we can first use is the time formula, which is T equals the square root of 2y over g. Now, we know y was 2 meters high, which is the height of the stair set. So we can just plug in 2 there, and then plug in 9.8 for gravity.
Plug-in time!
Oh yeah. And we end up getting 0.4 seconds for the entire time of the trajectory. Now, we can take that information and use it to find how far we went, or the range, the x value. And x equals vxt. Now, vx is 3 meters per second, and t is 0.4, and we end up getting a distance of 1.2 meters. Isn't that wonderful? So, from here to the end of his trajectory, which was a total time of 0.4 seconds, he went 1.2 meters.